So college credits taken by full-time students. We want to find the mean, the median, the mode, mid-range. Mid-range is easy. Maximum plus minimum divided by 2. What is the maximum?
18.
Minimum is 12. So the mid-range, 15. Minimum plus maximum divided by 2, which is 18 plus 12 over 2. We end up getting 30.
30.
Oh, 30 divided by 2. 30. We'll do the mean at the end. Mode is the most frequent observation. What is the mode? 16. I have 4 of them. Now, could we have more than one mode?
Yeah.
Absolutely. Sometimes you could have no mode at all. That is also possible.
How do you have no mode?
Huh?
How do you have no mode?
If we have unique observations, all 14 with different numbers.
So you don't put the 14 numbers, you just put no mode.
You would, I wouldn't. So I would simply write no mode. They're all equally likely. In other words, later on, the mode is connected to the shape. If you look at the bar graph or histogram, we always say the one with the range with the highest bar is the most frequent one. So the peak is where the mode is at. So if you have no mode at all, it's just flat. There are no peaks. We will go over that soon. Median, I showed you how to find this using the calculator, but I'll show it to you how to do this manually. But the difference between mean and median is like a person with amazing knife skills. So if you ask them to slice an apple, perfect, right to the middle, perfect half on this side, perfect half on that side, close to like nanograms, that perfect. Mean, on the other hand, it's me cutting an apple, never perfect, lopsided. So mean is affected by outliers. Median, on the other hand, it's like a perfect cut. It splits the data exactly in the middle. Any number that splits the data exactly in the middle. Could I pick 12 as the median?
No.
No. How about 17?
No.
How about 14?
No.
16?
No.
15? Maybe. We have 14 observations. So if I have to split so that I have equal number of observations on either side, I need 7 on this side, 7 on that side. So 1, 2, 3, 4, 5, 6, 7. There is no number right in the middle, so a reasonable number would be the average of the 2. Which is 15. And you can see most of the observations are very close to each other. Yes, even the mid-range is very close to the mode and the median. Yes.
What if we forgot how to find median on the calculator?
Patience.
Okay.
Let's do that. So we did this manually, great. But what if you had a large sample? Do you really want to do this? That's working hard. We have to work smart. I did show you last time, right? So how about you guys give it a try? I'll give you a couple of minutes and then I'll do it. So, last time we did this. So First, we've got to enter the dancer. So press 1. I have information there already. Don't delete them one at a time. So I'm simply going to press start again. Go over to number 4. Second 1. That would delete all the information or data points in list 1. Now I'm going to enter all the numbers.
Do they have to be in order?
No. So that's a good question. Sophia wants to know if they should be in order. No. They are the same numbers. Press start again, go over to calc, which stands for calculate. One variable statistics. And if you have the newer version of the calculator, it will say list, freq, and calculate. So older version, you'll simply have 1 mark starts. Either way, you simply do 1 mark starts, second 1. The very first line is the mean, which is 14.928. We can round mean, median to 2 decimal places, standard deviation to 2 decimal places. The only time where we would round stuff to 4 decimal places is with probability. So when we get to that, I'll remind you again. So the mean is 14.93. If we scroll down, the minimum is there. The map first would say that for later. What do you think MET stands for? Median. And max is 18. And we have everything we need. Yes.
Is Q1 4-time?
Yes. Good job. We'll get it tomorrow.
If you put the numbers like not in order, does it still give you the median?
Yes. So the numbers don't have to be in order. The calculator would order it for you. So it's working smart again. So the mean is 14.93. So if you observe, the observations are very close to each other, if not the observations. I mean, the mode, the mid-range, the median, the mean, they're all very close to each other. So that simply implies to me that there is no skew. Now you may ask me, well, how close is close? Well, 14.93, 15, fine. 14.93, 15.15. But if you had 20.93 here, that's way off, right? By all means, you can't have 20.93 because it's outside the data, right? We can verify this using a stem and leaf plot. Well, why don't you try it? Try a stem and leaf plot.
No.
Close.
Fair enough. Why did you put 5 on top and 5 on the bottom?
Huh? Just to get a good shape, that's all. You could put it either way. Yeah. So I just wanted a nicer shape. Just like a frequency histogram, if you had too many bars and very few observations, it's not going to be nice. So if I put the 5 there, I might get a funky picture. This is sort of funky too, but not bad, right? For a small sample, it doesn't have that much of a skew. And I mentioned it already, I didn't even have to, had to create the stem and leaf plot. Just by looking at those two values, I knew that there would not be a skew in that data. Does that make sense?
No.
Yes. Okay. So, same process as the previous one. So we want to find mean, median, mode, difference. What do you think the answers are? I want you to tell me.
Without our calculator?
Huh?
Without our calculator?
It's up to you, calculator, no calculator. So Hunter said, oh, the mean is 6.25. Nope, it's not correct.
2.96.
Julian is 8, well, don't I have to give specific numbers? What do we have here is a frequency distribution. Forget about frequency distribution. This is actually categorical data, right?
Yeah.
Right? Mean, median, mode, they're all for quantitative data, numerical data. That's not what we have. Yes? So we cannot find mean. I would have filled the test. None of these can be computed directly, and as Julian astutely pointed out, one way to do it is to specify 1, 2, 3, 4, and find the average of that, and round it to the nearest integer to find the mean. So I did want to do an example with a group data. So what I'm going to do is use this as an example, and then we'll do one more. So what I'm going to do is I'm going to call freshman as 1, sophomore 2, junior 3, senior 4. I'll call it Ken. So what type of quantitative data is this? Discrete. Okay, I code it, but is it ordinal? Is it normal?
Right now,
Well, it depends, because when you code it, it's nominal. No, never mind.
it's ordered.
Ordinal, why is that?
It's in order.
It's an order, that's why I wrote the number and then asked the question. It's an order, 1, 2, 3, 4, so ordinal. Okay. Now, how would we interpret this if I had to write the data? Since I have it coded, I'll probably say how many one, I'll write the number of ones. How many ones do I have?
2.
2. So 1, 1. Then I'd have 2, 2, 2, 2, 2. And then dot, 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 all the way till 4. That's too much work. Do you agree?
Yeah.
Do you really want to type in 25 numbers?
It's not really.
No. But we can use a calculator to compute the mean to break. So press start, number 4. We are going to delete everything in list 1. Go back to start, number 1. In list 1, I'm going to put the codes 1, 2, 3, 4. List 2, I'm going to put the frequency 2, 5, 10, 8. Good. Mind you, if I had data of this sort, I could have put everything in list 1, did one more statistics, list 1 would have gotten the answers. That's not what I have. I have codes and I have frequencies. So you have to find the measures of center for a frequency distribution. Now, even before we get into that part, if you have to guess the average, most physics students are what level?
Junior.
We kind of say that the highest frequency is right here, so it's likely to be junior. Let's see. If you have the newer version of the calculator, now is when we're going to make use of list and freq. So list 1, that'll be list 2 and
There we go.
Oh, now it's more, okay, so like you can, like, it would be the same thing, just so I understand. Like, let's say that you decided for some reason to put the frequencies in list three.
There.
it'll be L2 L2.
L1 and L3.
Yes.
Okay, I figured
So if you have the older version of the calculator, it's simply 1 bar starts L1, comma, L2. The mean is 2.96, which is good.
there's not much.
Still, I didn't expect that to happen. Do you think we will have skew in this
No.
data? No. Yes or no?
No. Well, in that, well,
So you have more here, less
To the
there,
left here.
right? So it's skewed to the left. But coding like this is not a good idea because had I switched it and wrote it as 4, 3, 2, 1, the average would switch, right? So we've got to be careful anytime we code and get a frequency distribution. Using the same idea, we can now do one with quantitative data. So it simply says fuel economy of 30 small cars. But where did that number 30 come from?
it's a total frequencies.
If you add all the frequencies, it will sum to 30. Okay, great. In the previous case, I coded that the values were kind of weird. Because it's qualitative data, we can write it out this way and compute, the mean, the median, whatever we do. Here, we have intervals, right? 29 to 33, 34, 38, 39, 43. How would we find the mean? This is a frequency distribution also, but this time we have quantitative data, but we do have intervals there. So any thoughts?
Midpoint.
Very good. We use the midpoints right there in list 1, and we can get the mean to regular.
So write it as code.
No. Don't convert it to a code, you have to just use the midpoint. We did it last time because it was what type of data?
Ordinal.
Qualitative.
Ordinal qualitative data. So, what is the midpoint of 29 to 33? 31. The next one,
36.
36,
41. 46.
46. Enter the frequency, 11, 12, 2, 5. I'm thinking data is clearly skewed. This is numerical. I'm expecting the values to be somewhere like there. We will see. Start over to calc. And this is where, once again, if you have the newer models, you should specify list 1, trick would be list 2 and calculate. Older version, second 1, comma, second 2. Good. In this case, it makes perfect sense because it is quantitative data. And we said that data has, the average has to be somewhere here because the majority of the observations are right here. Yes, Hunter.
So when we're doing the mode for these set of values, do we do the midpoint as well, or do we do the?
It will be the midpoint. Okay. Very good question. So most of them are right here. So the average has to be somewhere here. So we get 36.17. The number of observations is 30. The median is 36. Good. Now, the mode, on the other hand, would be the most frequent observation. By all means, it is not reasonable to use mode for this data. Because can you tell me what the most frequent would be? Observation between 34 and 38? I don't know. All I can say is that interval is most frequent. So mode is not a great measure for this data. Are you with me?
So do we not put it?
If there is the question, what is the mode? The answer would be no. Because if it's a single observation, you don't have a single observation. All we know is the most frequent interval or class, which is 34 to 38.
And to calculate mid-range, do we use the midpoints or do we just not calculate it?
We just don't have to.
Oh, you want to calculate this?
Yeah, because you don't have a minimum and a maximum. Right?
Okay.
So that is also a good question. So even though we start at 29, end at 48, remember there are many ways to create a frequency distribution. What if the beginning value was actually 30 and they did some adjustments to get to, 29? Let's not make that assumption. Okay.
Would that be the same in the previous situation?
Frequency distribution and mean of frequency distribution is called weighted mean. It's mean that simply where we multiply the observation with its corresponding weight, and we divide it by the sum of all weights.
What the little symbol mean?
Sum. So sum. So you multiply observation with weight and divide by the sum.
Observation meaning like the number of observations.
Yes.
Like in this case, 30.
Yes. Now, oftentimes people would ask, well, which should be the weight and which should be, the sum of all observations. It's not weights, observations, not that. Think of it this way. We do this every day, or every semester with GPAs, right? How do you compute your GPA? Each grade has a corresponding value, right? A point that is assigned. So the value would be the weight. And the observation would simply be the number of credit hours that you would have. So in the GPA example, all you would do is to take number of credit hours, and the corresponding grade, multiplied by the corresponding GPA value. And you would divide it by the total number of credit hours for that particular semester. Yes? Have we done this manually before? So this is what we call weighted mean. And oftentimes people would say, well, which is the weight, which is the observation? Well, typically the weight is the value that you have, or the value that you put. The observation here is simply the frequency or the count that we have. Does that make
The
sense?
number of options.
It's the number of observations for each case. So for this GPA value, you had a count, maybe 4 credit hours. So you made an A in one class, which had 3 credit hours. So it would be 4 multiplied by 3. Value, frequency. Does that make sense? Yes. Okay.
I probably just. What? No.
It is 600, it's not 600.
Okay, so just to recap, so you take the weight is typically the value, multiply the frequency, so 523 times 24, 2,415 times 2, 250 times 4, divided by the sum of all frequencies, and that would be the weighted mean. So the weighted daily balance for the month of April for that particular account, 612.7. Very good. Okay. Where is the count frequency? Okay, so we have scores and from 3 different majors. You have engineering, math, business. These are the number of students in each major, and that is the corresponding score. I think it's the math. So, and we want to find the weighted mean. So all we have to do is recognize that these are the frequencies of the observations, and that is the value. So 9 times 85 plus 5 times 90 plus 13 times 81. Divided by the sum of the count or the frequencies. And what do we get? 84. 80. Okay, don't make the mistake of adding these in the denominator and dividing it into one constant. Oftentimes, a bit of common sense in a problem like this, okay, majority is over here and there, so the average has to lie somewhere between 81 and 85, right? So we get 84. Process of elimination on an exam always works. So the last topic for today is skewness, and this is the last topic in 2.3. On Tuesday we start 2.4. So what is skewness? The skew means to pull something in one direction. So if you have a histogram, you know, 5, 10, and that's what you have. Now, do you see a shape?
Square.
Square.
Yeah,
Could be a
box.
rectangle,
It's a, well, sure.
but it
Box.
looks like a box, right?
Yeah.
So, do you see a predominant peak somewhere? No. So, this is the kind of data that does not have a mode. Right? A mode is where you have a dominant peak, so no peaks found. So no mode. No skew. Doesn't have a skew. It's just uniform everywhere. This is what we call a uniform histogram. What it, it's a bulk. It looks like the castle in Ascot.
God, you're right.
Some numbers, 2 to 12, and this has no skew. And it is symmetric. In the sense it's symmetric about the mean. So the mean's probably there. And do we see a predominant peak?
Yes.
Yes, and where does that peak occur? Right here, right? So the mean median and the mode, they will all be approximately equal to each other if the data has no skew and if it is symmetric. That makes sense. So mean, median, mode always be equal. Doesn't apply in that case because it doesn't have them. Do we see a skew?
Yes,
Which side is the
to the
skew?
left, no, to the
Right.
right.
To the right. So the pull happens here. A few observations on the right hand side pull the data. Majority of them are right here. So this is right or positive skew. In a case like this, the mean is likely to be bigger than the median, which is likely to be bigger than the mode. Now, do you see as to why I mentioned I usually know if the data has skew or not, depending on how these two vary, right? If they are pretty much the same, then you don't have a skew at all, nearly symmetric. But if the mean is bigger than median, then the data is right skew. Now, what do we expect in the case of the left skew?
The
The complete opposite.
The complete opposite. Something like that, and the skew is on the left hand side. So this is left or negative skew. Here, the mean will be less than median, which will be less than the mode. It sort of makes sense. The mode is right here, correct? The average of all of those cannot be right. There's probably somewhere here. Agreed? Because there are some here, some there. The median is probably here as well. This inequality doesn't always work, but 90% of the time it works. So no skew, symmetric, mean, median, mode are the same. Easier way to remember for these two cases, look at the signs. If, it's pointing to the right, so for right skew means bigger than medium, which is bigger than mode. There, pointing to the left means less than medium, less than mode. Good. Any questions here?
Okay.